In this video, we are going to design a move finite sequential machine using verilog. For that one, go to File, click New Project, create a new Vivado project. Project name is 37 RTL project. Click Next. Board is basis 3 board. Give Next. Finish. Go to Add or Create Design Source. Create file. FSM is a file name. Give Finish. Give OK. So this is my program. Okay, so before that one, the aim is to design and implement a more finite state machine using verilog HDL. For that one, I require Xilinx Vivado 2017.1 FPGA board is basis 3 board. So this is my more machine state machine. Okay, so I'm going to deduct. So this is a diagram for sequence detector. Okay, so this arrow mark determine the in sequence value. Okay, so when it is 1, it goes to the state 1. When it is 0, it goes to the state 2. When it is 1, it goes to the state 3. Okay, since that is detecting 101. So if 101 is detected, the state 3 becomes 1. Okay, so this bar 1 represent output. Okay, and that is sequence is detected. So why this S0 is going to 1 means if it is 1 means it goes to S1 state, means S1 value is 1 and S0 value is 0. So if it is 0, it will remains in the same state. Since if S1 is 1, it will be in the same state because S1 value is 1. If it is 0, it is going to S2. So what is the value of S2? S2 value is 1, 0. Okay, and if it is 0, it is going to S0 because the S0 value is 0. If it is 1, it is going to S3 because S3 value is 101. So 1010, if it 0 means it will go to S0. Okay, so if it is 1 means it will go to S1. That is 1011. So if it is 1 means it will go to S1. So here one arrow mark is missing. Okay, so this is what we are going to for this hardware we are going to write the verilog program. Okay, so this is my program. I just copy this program. So here you can see module name, clock, reset, X and Y. X is my in sequence, that is X is my input value and Y is my output. Okay, so totally I have 4 state that value 0, 0, 0, 1, 1, 0 and 1, 1. Okay, so it is, since it is 2-bit, I am writing register 1 is 0 of state, and next state value also it is 2-bit. Okay, I have present state and next state. Okay, always at the positive edge of the clock or positive edge of the reset begin. If reset is 1, the initial state value is S0, else it will go to the next state. So always at start begin case when it is S0, that is 0, 0. The next state values, if it is 1, it will go to S1. It is called as conditional statement. So if by X value is 1, it will go to S1. If it is 0, it will go to S0, right? So you can see the diagram. If X value, this is X value is 1, it will go to S1. If it is 0, it will remain in the same state. Likewise for S1, if it is 1, it will be in the S1 state or it will go to S2. So whenever the present state is S1, the next state, when it is 0, it will go to S2 state. When it is 1, it will remains in the same state. Okay, for S2, when it is 1, it will go to S3. When it is 0, it will go to S0. You can refer the diagram. For S3, when it is 1, it will go to S1 or it will go to S0. Okay, so the default state is S0. So end case end. Okay. Always at the state. So you have to write it for output also, no? So begin case whenever the S0, S1, S2, output value is 0. For S3 only, output value is 1. Default value of output is 0. End case end and end model. So let us save this program, run the synthesis. Okay. So next, let us discuss. Let me write the test bench program for this one. So module test bench name. Inputs are clock, reset, and X. Output is Y. I'm calling this program clock, reset, X, and Y. The clock is changing from 0 to 1 after 5.5 seconds. Initially clock is 0, reset is 1, X is equal to 0, and X is equal to reset is equal to 0. So you can see I'm giving the X value as 101. How many times I'm giving 101? 1. So here also this is called as overlapping. Okay, so here this is 101, and here also I'm having 101, and here I'm having 101, and here also I'm having 101, and here also I'm having 101. Okay, so this is nothing but overlapping. If it is non-overlapping, means this is 101 and this is 101, this is another 101. So totally I have 3 101 if it is non-overlapping, and if I have 5 101 if it is overlapping. Okay, so let me copy this program. The implemented design is successful. Go to source, create simulation source, create file, save this program, run the simulation. So if I have 5 output means 5 output as 1 means it is overlapping. So here you can see I am having only 3 outputs. Okay, so it is nothing but non-overlapping. Okay, so the program is successful. I am going to write the top module program. Okay, so module, the top module program name, clock and reset, that is machine reset in sequence, and I am giving a BTN pin. Okay, output as LED. Okay, and here the wire is DG and register T in of reg. So always at the positive value, positive edge of the BTN. Okay, BTN or positive edge of the machine reset begin. If machine reset is 1, D in register value, D in register is equal to 0. Otherwise, whatever the input that is sequence I am giving, it is stored in the DIN register. Okay. Then more FSM. So I'm calling the previous program UUT clock and changing it as BTN pin. Okay, so it is a nothing but I'm going to give the push button pin, and reset is a machine reset here, and X is nothing but DIN register here. Okay, and Y I'm giving it as DG. Okay, and the DG I'm going to assign it to LED. So I hope this program, you can understand this program. So just copy this program. I'm just creating an design source. Click yes. I'm saving this program. So now this becomes a top module. So I'm going to open the constraint file. Okay. So if you see the constraint file, I have a BTN clock in sequence LED and reset. So LED is my output that I have given to L1 pin, and reset pin is V17 pin, and in sequence is my input, so I am giving it to R2, and the clock is W5, and BTN pin is T17 pin. Okay. So just copy and paste it here. So you can see here, so here instead of clock I am giving the BTN pin as my clock. Okay. So I'm just saving this program. Click generate bit string. So this will take some time. Let me pause this video. Initialize the design. Running root design. Running write bit string. I'll click the generate bit string. So running system design, running as a writer. Now let us click the auto connect. Open target. Auto connect. Program device. So first let us press the reset button. So if I press reset button, then the initial state will be in 0. Then I am the input as 1 and pressing the clock BTN pin, and making the input as 0. Then I am pressing the clock BTN pin. Then making input as 1 and pressing the clock pin. Then if I press the clock pin, it becomes 1. If I again press the BTN pin, it goes to 0. So even when the input is 1, you will get the output. Okay.